How Planes Fly by Asa Baker-Rouse. Have you ever wondered how a plane flies? Why doesn't it just fall out of the sky? Planes are heavy. We all know that gravity is the force that pulls everything towards the earth. And so planes shouldn't be able to get off the ground. But they do. This is because of lift. Lift is the force that holds the plane and keeps it from falling out of the sky. This is why the plane stays up. But there are two other forces, thrust and drag. Thrust is the force that powers the plane forward, and drag is the force of the air slowing the plane down. When lift beats gravity and thrust beats drag, you have liftoff. This is the fuselage. It is the main body of the plane. The fuselage is where the pilots and the passengers sit. It acts as a stabilizer for the wings and a place to sit. The engine is on the wing typically. They are the part of the plane that provides thrust, the force which pulls the plane forward, but only just enough to overcome drag. The rudder is on the tail and can move, unlike the normal tail. It steers the plane when it is in taxi, getting onto the runway, and in flight helps keep the plane from crashing. The elevators are on the tail and can also move. They put the nose of the plane up or down and can control how fast the plane can go before it stalls and crashes. The ailerons and flaps are parts of the wing and can move. Ailerons turn the plane like a bicycle by tipping it to the side. With the rudder to help the plane from turning the wrong way, they can turn any way you want. Flaps are like a brake. They slow the plane down, but also provide it lift. So, they are used for landing to slow the descent with slowing air and providing upward force to the downward going plane. In order to understand how wings work, you must understand a bit about air. Air is a fluid. It is a gas, but it is also considered a fluid, meaning it is a substance that is easily compressed unless it is at the speed of sound. Water is another fluid. Because air and water act the same way, but you can see water, it is easier to imagine that the plane is in water to better understand aerodynamics, the science of flight. Wings provide lift to the plane and drag slows the plane down. The wing has to be a specific shape. The Wright brothers were the first to come up with the shape through wing warping. They learned that the wings on a plane have to be fixed in order to provide enough lift. They figured this out by testing many different shapes of wings in a wind tunnel, a box which wind is blown in to test planes. Since then, we have developed the wing shape that we now call an airfoil. The wing is in an airfoil shape so that it can provide lift. It has a flat bottom and rounded top. This is because, like water, air wants to take the shortest path around an object. As the plane moves, the air is forced along the bottom of the wing because it is flatter. The air molecules go faster. On the top, the molecules are going a longer distance and they are slower to get to the edge of the wing. The air molecules on the bottom form a wall of high pressure that holds the plane in the air, while the slower molecules on the top don't give as much push, lower air pressure. So the plane is held in the air. The reason the plane is lifted is because of the downward deflection of air. Newton's law says every action has an equal and opposite reaction. So when the trailing of edge of the wing is down and the air is deflected down, the plane is propelled upward. The angle at which the leading edge of the wing meets the air is called the angle of attack. Drag is just the air hitting the plane and slowing it down. The reason is because the air that isn't moving is suddenly hit by the moving plane and does not want to move out of its way. If you have ever stuck your hand out of a moving car, you can feel a wind even if it isn't windy outside. This is called relative wind. Relative wind is an air felt by the airfoil. Imagine again that the air is water. Water moves more gently across smooth, rounded things than across bumpy, jagged things. Air is the same. So the air will move smoothly over an airfoil and the rounded nose of the plane than a bumpy, jagged boulder. This is why planes have rounded edges, especially on the fuselage, where the drag is most felt. The more downward deflection you have, the more lift you have, and the greater angle of attack you have. However, the greater the surface area of the wing, the more drag it will have. The lift is best at a 4-degree angle of attack. Lift and drag are balanced at about 3.5 degrees. At about 15 degrees, the wing stalls because there is more drag than lift, and the plane crashes. This is the reason most flaps provide lift and drag. Because they are detached from the wing, they can tilt downwards to get more lift and more drag. Ailerons also work this way. One aileron goes up and gets less lift, and one goes down, getting more lift, which tilts it, which turns it. Elevators are also airfoils, just on the tail. The elevators point the nose up or down in order to increase or decrease the angle of attack. The engines must make the air go faster over the wings, increasing lift. So when the engines go slow, the plane must have a high angle of attack, or mush, to stay at the same height. When the engines are faster, the plane can be at a low angle of attack to maintain height. Engines are the part of the plane that provides thrust by sucking in air one end and pushing it out the other. They push enough air out to overcome drag, which is slowing the plane down. If you have ever blown up a balloon and let go, it will shoot across the room because the air is being pushed out. An engine works the same way. Two types of engines are the propeller and the jet engine. The propeller is a very powerful fan and works just like one. But instead of a gentle breeze to cool you down, it provides a wind to get the plane going. A jet engine is more powerful and is used for bigger planes. It is made of many propellers or turbines that all push air out to provide more thrust. A law of science says that every action has an equal and opposite reaction. So, when the engines push out air from the back, they are pushed forward, propelling the plane with them. Now that you know about the wings, let's talk about the fuselage and the tail. Without a fuselage and a tail, the plane would only be wings with engines on them. This would not work because the fuselage acts as a lever where the fulcrum is underneath the center of the wings. The tail is the effort, pointing the nose, which is the load, up or down like a seesaw. Without the fuselage and tail, the wings would climb and dive hopelessly. You know now that you need a fuselage, but do you need a pilot? If the plane had no pilot, it would not fly level. The wind would change and the plane would not be able to adjust to get more or less lift, so it would crash. This is called stability. The plane wants to do the right thing, but cannot adjust to different air pressures, winds, and temperature. The plane is balanced because the wings are the same weight. The fuselage is nose-heavy, but the air from the engines across the tail keeps it down, just like if you poured water over a toy plane on a spring. The tailplane and elevators move the nose up and down, controlling the angle of attack. But what does the tail fin and rudder do? Well, The tail fin provides stability with turning, but the rudder isn't really needed. It's used in taxiing to turn and to prevent the plane from having wind and drag upset its turn, but it does not turn the plane and is not really needed. The tail fin is needed, but the rudder has not been on some planes and is not needed. This is why planes need a fuselage and tail, but not a rudder. To summarize what you have learned about aerodynamics, lift is the force provided by the air molecules being deflected downwards by the wings. Drag is the air pulling on the plane and slowing it down. Thrust is the force of the engines pushing the plane forward. Gravity is the force pulling the planes down. Now that you know the basics of flight, some vocabulary words. Pitch is rotating on the lateral axis. It moves the nose up or down and is controlled by the elevators. Roll. Roll moves on the longitudinal axis. It tips the plane from side to side and is controlled by the ailerons. Yaw. Yaw turns on the vertical axis. It rotates the plane from left to right and is controlled by the rudder, but the ailerons really do the work. Pitch, roll, and yaw are some of the basic maneuvers a pilot can complete and are used in many tricks. This is what the pilot sees when they are in the cockpit. Here is what some basic instruments do. Altimeter. The altimeter shows how high the plane is above sea level. The vertical speed indicator shows how fast you are going up or how fast your vertical speed is. The airspeed indicator shows you how fast you are going through the air. The inclinometer shows how your turn is oriented against the horizon. The attitude indicator shows you where your nose is, what angle of attack you have, against the horizon. The heading indicator shows which direction you are heading, north, east, west, or south. The yoke, which is sometimes a joystick or stick, controls the ailerons and elevators. Back will point the nose up, forward, down, and left, you turn left, right, you turn right. The throttle controls how fast the engines are sucking air in and pushing it out, providing more thrust and lift. These are some of the basic controls and instruments the pilot has to work with. There are many others that some pilots use, but these are the main controls. This is what a pilot needs to know in order to fly in stable flight, landing, and takeoff. You now know the basics of flight and can impress your friends. Fly high, and I'll see you soon. Goodbye.